Okay, some more problems from section 6.2, and this is number 15. And again, we just wanted to show that the f of u du was different than the f of u dx. So f of u was e to the u, and u was 7x. So if I want to take the antiderivative of this, this is all set. E to the u du is just equal to e to the u plus c. And then to get that in terms of x, I can just substitute x in there. So I get e to the 7x plus c. So this is fine. Now over here, okay, I've got e to the u dx. So now I've got to get this all in terms of x. So I'm going to write this as the integral of e to the 7x dx. Okay. Now I got to go back in circles, kind of, so hopefully this doesn't confuse you. Think of this as a different problem, so don't be looking up here. Let's think of this. How am I going to take the antiderivative of this? Well, I'm going to have to use the u substitution, okay, because I don't have enough over here, so I'm going to have to write this as e to the u du. So I'll rewrite this. First of all, I'm going to let u equals 7x. So this is a little different than the other u, so I hope that doesn't bother you. So let u equals 7x. And I'll write this as the integral of e to the u dx. Now these don't match, so now I'm going to have to find out what dx is. So I'll take the derivative of this. So du equals 7dx. And I almost have a match, like I was doing earlier. In other words, I look over here, I see a dx. This is what I want. So what I'll do is I'll divide both sides by 7, so I get du divided by 7 equals dx, and now I do have a match. Okay, so what I can do is I can rewrite this now as the integral of e to the u, and then that's going to be du over 7. Then I can take that 7 in front, so that's going to be 1 over 7 times the integral of e to the u du. Now you can see that that's not the same as what we had up here on the top. So I definitely know they're different, but I'll go ahead and substitute all the way through so you can see this. All right? So this is going to end up being equal to 1 over 7, and then the antiderivative of that is just e to the u plus c, and then u is what? 7x. So this ends up being 1/7 e to the 7x plus c. And you see, those two are different. This is one, and this is the other. So this was the f of u du, and this is the f of u dx. And you see they're a little different by that 1/7. So I think that's what they wanted you to show. Okay? All right, let's take a look at the other ones. Now use the indicated substitution to evaluate the integral. And then confirm your answer by differentiation. All right, so we have number 17. And this is the integral of the sine of 3x dx. So again, I'm going to have to use u substitution. This is 6.2 homework. Okay. So I'm going to let, they actually gave you the u, let u equal 3x, so they told you that. So I can rewrite this as the integral of the sine of u dx. But now we've got u and dx, so u and x, so we've got to fix this over here. So du equals 3 dx, so dx equals du over 3. Now I have a match. I have dx here and dx here. So what I can do is I can just substitute. So I have the integral of sine of u, and then that's going to be du over 3. And then I can take that 3 and bring it out in front. So I've got 1/3 times the integral of the sine of u du. And now I've got my formulas over on 332. And on 332, what's the antiderivative of the sine of u du? They've got that right over there. That's negative cosine of u. So I've got a 1/3 in front. And then I got negative cosine of u plus c. And I can multiply this negative 1/3, or this 1/3 would end up being negative 1/3 cosine, and instead of u, what can I put? 3x plus c, and there's your final answer. Okay, so that's the integral of the sine of 3x dx. Then they want you to check that bionic differentiation, so that's going to be kind of a pain over here, but we'll do it. So we'll take the derivative with respect to x, and this is kind of like we did on the second three problems, of negative 1/3 cosine of 3x plus c. And the derivative of this will be negative 1/3. And what's the derivative of the cosine? The derivative of the cosine is negative the sine of 3x times 3 for the chain rule, and the derivative of c is 0. And a negative times a negative is a positive, and 1/3 of 3 is 1, so we just end up with the sine of 3x. So you see they do check out. Okay, that was number 17 with the check, all right? And make sure you guys do that. I know some of you aren't going to want to do that, but that's what they ask you to do. That's what I've done, so make sure you check it. Okay, and then number 19. Probably going to need a whole page for these, so I better just get over there and do it like this. Here's number 19. And we got the secant 2x tangent 2x dx. So the integral of the secant 2x tangent 2x and they wanted you to let u equal 2x. So u equals 2x. So I'll put my substitution in. So I've got the integral of the secant of u tangent of u dx, and remember the derivative of this of the secant is a secant tangent, so it looks like I got a nice antiderivative, except I have to have a du, not a dx. Okay, that's one of my formulas. I think it's on page 332. You see your formula. It's given to you right over there, and I see the integral of the secant tangent is secant plus c, but it has to be du. So I'll take the derivative up here. The du equals 2 dx. Remember, it's understood to be a du over dx, but they're the same on both sides, so we just write the tops. Then divide both sides by 2, so dx equals du over 2. So now I can substitute. Instead of writing dx, I'll write du over 2. So now I've got the integral of the secant of u tangent of u, and that's going to be du over 2, and then I can put that 2 in front as 1/2, so 1/2 times the integral of the secant of u tangent of u, and that's du. And that's right out of my formulas over there. So it's going to be 1/2, and this is going to be the secant of u plus c. Okay, and then what I can do after that, and again you see that right over there on page 332, you look at that formula, and then we can put the 1/2 secant, but instead of u, what will I write? U is equal to 2x plus c. And there's your final answer. Then they want you to check it. So this is the check, so that's like the fun part. So I want to take the derivative with respect to x of 1/2 the secant of 2x plus c, and that's going to be 1/2, and the derivative of the secant is secant 2x tangent 2x times 2, and the derivative of c is 0. And see how these 2's cancel, so that ends up equaling secant 2x tan 2x, oops, sorry, yeah, right over here, secant 2x tangent of 2x. And that's what we had up at the beginning. So we show that they're the same. Okay? So that's what you've got. I'll go up here. There you go. So that's the same as that. Okay, and then number 21. Okay, 21's a little more interesting. Definitely need a full sheet for this, and we'll have to catch that one in the next video because it's going to be kind of long.